In this video, I'm going to be going over the mean value theorem question, where we have to deal with some inequalities, including this one over here. So I'm not really going to read all of that yet. Let's actually look at the question. This actually popped up in one of my final examinations for mathematics, with Calculus 1. So I'm actually going to do this right now, because I actually kind of struggled in the examination with this one, because I was not prepared. But what I'm going to do now, I'm actually prepared and I have a solution and I've actually solved it, and now therefore I'm going to share it with you guys, because I am a math content creator and I have to. I'm forced against my will. I have a gun pointed to my head. No, I'm joking. Okay, so we have the following question. It's for 5 marks, by the way. 5 marks, and this is a, oh my goodness, I can't even fathom how long it took me to get the answer. Use the mean value theorem to show that for all x is greater than 0, x values that are greater than 0, meaning positive, right? X greater than 0 is positive. That x over 1 plus x squared is less than arctan of x, which is also less than x. All right, now where do we start? The first thing that you want to do is the following. The first thing you need to do is you need to state the mean value theorem so that you can have a great understanding. You need to state the mean value theorem to your examiner. So mean value theorem states that a function, right, is continuous. It's continuous on a closed interval from a to b, and it's also differentiable on an open interval from a to b, so that there will exist, so I'll say so that there exists a c value which is within that closed interval, within the interval of a and b. So therefore the c must lie inside of the interval between a and b, such that, there's even more. We have the following formula: f prime of c is equal to f of b minus f of a all over b minus a. Now, why does this look so familiar? This is actually a gradient formula, right? Where we have f prime of c, we know that the first derivative of a function is normally the gradient, represented by the gradient, right? And because of that information, then we would have something like this, right? This is obviously represented as the delta y, and this is represented as the delta x, meaning the y2 minus y1 over the y minus the y initial, all over the x minus the x initial. Okay, so mean value theorem states that a function is continuous in the closed interval of a to b, and differentiable in the open interval a to b, so that there exists a c value that lies between a and b, such that f prime of c is equal to f of b minus f of a all over b minus a. Okay, now that we have stated it, what we are going to do, and we also got the conditions inside of that theorem. So what we are going to do is we're going to say choose, right? So normally this is where we choose our variables, and I want to choose the following, right? So first of all, we are going to choose a to be equal to, and I'm going to say 0, and then we're going to choose b to be equal to x. Now, why am I saying this? So let's look at the closed interval of a and b, right? We can see that we chose a to be equal to 0. So we are going to write closed interval of between 0 and our b, which is going to be x, right? Now, the reason why it's a closed interval is because we need to actually use mean value theorem. And if we don't use a closed interval for in terms of mean value theorem, then we are not using mean value theorem. So that is why I let a equal to 0 over here. I know your condition says that where x is greater than 0, but to make mean value theorem true, we need to let a equal to 0, such that it starts at 0, right? And then x is equal to b. So it's any value, so it's going to lie between a certain value x, between 0 and a certain value x. That is what I'm trying to say over here. So we need to stay true to mean value theorem. Next thing I'm going to do is I'm going to assign a new variable. Let's call it t, f of t, right? I would choose, the reason why I'm not saying f of, so let me just do this first and then I'll explain. Arctan of t. Now the reason why I'm not saying x is because we're going to have some differences over here. And x is actually equal to b. So that's why I don't want to confuse it. I want to use a completely different variable so that we can actually express our answers correctly according to the correct mathematics here and mean value theorem. Now I'll show you later on why this is important. But let's first consider the following, right? Let's consider the mean value theorem with f prime of c is equal to f of b minus f of a all over b minus a, right? Now what we can notice over here is the following, that we need to look for f of b and we also need to look for f of a because we already know that a is equal to 0 and b is equal to x, so we can already substitute immediately. But let's look at f of 0. F of b. F of b is equal to, that means we're substituting b into c, into t basically, right, for our inverse function. So f of b is equal to arctan of b, which is equal to arctan of x. Now you can see why I assigned a new variable, because now we're going to have x, right? We want something in terms of x and not b. So that is what we're going to say over here. F prime of c is equal to arctan of b minus, okay, now we need to see arctan of a, f of a, right? We need to find f of a, and that's going to be arctan of a, and which is basically, we know a is equal to 0 because we assigned it, and therefore we're going to have arctan of 0 over here. So we're going to say minus arctan of 0. Sorry, this was supposed to be x, by the way. Okay, and then we're going to replace our b and our a. We know b is equal to x, and our a value is equal to 0. Now we simplify. What is arctan of 0? Now, if we look at our arctan function, which goes as follows, we have a y-axis here, and we have an x-axis here, and we have so it's y and x. We're going to have asymptotes, which look like this, right? It's going to be here and here. This asymptote is going to be pi over 2. This is going to be negative pi over 2. You must remember your inverse trig functions for these stuff, because if you don't know it, then you are actually screwed for the examinations, because they actually expect you to learn these. But the arctan function goes as follows. It starts over here. Well, it doesn't start. It passes the origin line such that it increases when x is positive, and I'm trying to say that it looks like this basically. Sorry, I don't want to confuse it anymore. So that's our arctan function. So we can say arctan of x, basically. What? Go back. Great. So that's arctan of x. Now, what we are going to do here is we are going to simplify. Arctan of 0, we can clearly see that arctan of 0, the point 0, and is basically a part of the origin, right? So it passes 0 by the origin. Therefore, the answer of arctan of 0 is just going to be 0. So it's going to be arctan of x minus 0, so we don't have to write it because 0 doesn't really change anything. And x minus 0 is just equal to x. So f prime of c is just going to be equal to arctan of x over x. Now that we have dealt with that, we need to differentiate our arctan so that we can get further into the proof. Because what we can see over here is it kind of looks something like the derivative of arctan of x. And the derivative of arctan of x looks as follows, right? We have d by dx is of arctan of x is going to be equal to 1 over 1 plus x squared, right? And if we look at our function f of t, right, which we have assigned the new variables, f of t is equal to arctan of t. We're going to just write it again. F of t, that's not like that. f of t is equal to arctan of t. We're going to differentiate it, right, such that we get the first derivative. And what we have just done here on this side, we're just going to replace the x with t. Because I know students normally like to remember their derivatives of their trig functions in terms of x. So what I'm going to do is I'm just going to replace it with a t now. So it's going to be 1 over 1 plus, instead of x squared, it's now t squared. Okay, now how does this help us? What we can see over here is we have f prime of t. And what is the closest thing we do have so that we can actually assign this equal to something else? If we replace t with c, we'll get the following. Okay, so what we're going to do over here is we're going to say let t equal to c, right? Because we haven't assigned c yet to anything. So that makes it easier for us. And that's exactly why I assigned a new variable. You see, it's much easier for us to deal with these proofs. So therefore, we're going to say f prime of c, because we're replacing t with c, is going to be equal to 1 over 1 plus c squared, which is also equal to something else, which was arctan of x over x. Nice. Now, what we have is the following. So let's consider the following over here, right? Remember that c needs to lie in the interval between a and b, right? And what is a? A was equal to 0 that we assigned, and b was equal to x, right? So what we are saying is the following. If we look at the inequality here, right? So let's focus on this for now. We have c is less than x, right? And because of that, we can say over here that 1 plus c squared by okay, no, sorry, I'm skipping over here. I already had a solution. That's why I already know what to do. So what we are saying, we're going to take these two, right? And we're going to try and bold something like this, where we have 1 over 1 plus c squared. Because remember, it's a proof question, and we need to use the inequalities. We need to get into inequality form from the beginning of the question, if you can remember. Okay, so what we should know over here is that 1 plus c squared is less than 1 plus x squared. That's the reason why I'm doing this is the following. If we can do it like this, we can actually say that if we follow logic, right? If we say that, let's say c is equal to, for example, 2, and x is equal to 3, we can actually say that 1 plus c squared, which is going to be 2 squared, right, is less than 1 plus 3 squared, according to what we have here. And then, when we simplify it, we can have 1 plus 2 squared, which is 5, and 1 plus 3 squared, which is 10. And according to the logic, once again, that is exactly what's going to be happening over here. We know that c is less than x. And if we apply this over here, by just a random example, you can even do this in pencil on your question paper, and you can understand why that's true. Therefore, that will prove that this inequality over here is true. And what we need to do is the following. We need to say over here that, remember, we need to get 1 over c squared, right? And in order to do that, we need to inverse both sides. And I'm going to try and keep the inequality like this, but we can see now that the 1 over 1 plus x squared will be on this side. And then 1 over 1 plus c squared will be here. It was basically from what we did, it actually looks something like this, right? It would have, if you would have kept the sign like this, if we would change it like this, it would be 1 over 1 plus c squared, and then this would be 1 over 1 plus x squared. If you were to look at it like this, right? But I'm keeping it like this because I want to do the proof with ease. Okay, now let's look at the following, right? In the beginning, we had an inequality of 3, right? We had 1, we have 2, and we have a third part of the inequality. Now, how do we get to this part over here? Now, I'm going to show you exactly how we get to that part. After this thing stops being ridiculous. So I think I should actually take it like that from now on. Okay, So we need to actually complete this inequality. Now I'm going to write it like this. 1 plus x squared less than 1 over 1 plus c squared is going to be less than. Now, how do we find these values? Let's look at the inequality we have looked at in the beginning before we actually bolt the inequalities, right, over here. We're going to look at this over here. And remember, we use these, right? But what about this? Let's use some more logic here. I know this is a whole logical question over here, and that's crazy how they can fit this in the final examination. They obviously had to have that intense question. So, what we know by logic is that over here, if the denominator, so let's first look at here, right? The denominator here is obviously going to be greater than this denominator here. Because if we look at, let's say 1 over 2, this is going to be equal to, in decimal form, 0,5. If we look at 1 over 4, this is going to be 0,25. And you see how it gets smaller the more we increase the denominator. And if we have 1 over 8, this is going to be 0,125. And you can once again see it's getting smaller and smaller and smaller. And basically what we are saying over here is that 1 over 4 is less than 1 over 8. If we try and relate it to this one over here. This is based on the logic that we have. 1 over 4 is basically less... sorry. That was the wrong way around. It was 1 over 8 is less than 1 over 4. That is based on the logic we had over here. I just had to look at it again. All right. Now, because of that, what we have left is 0, right? Over here. So which means we need to have something exactly like this fraction, but let's write 0 instead, because we have x over here. So let me just get rid of this so you don't have any confusion. So we have x here and here. And we also have c over here and over here. So what about 0? Let's do the exact same thing. And let me get rid of this here. Okay, so if we say 1 over 1 plus 0 square, right? And this will actually just say that it's going to be 1 over 1 plus x square less than 1 over 1 plus c square, which is less than 1 over 1 plus 0 square, which is a 0, or we can just write it as 1. It's a simple answer. Okay, now how are we getting to the answer? This is how we do it, right? What do we know about 1 over 1 plus c square? 1 over 1 plus c square is equal to arctan of x over x. So we just replace it with that one. So it's going to be 1 over 1 plus x square is less than arctan of x over x, which is also less than 1. Okay, and now we see we're getting somewhere. Just one more step. Multiply all sides by x, so we can get rid of this denominator over there, and we multiply this by x over here, and we also multiply this side by x, such that on this side the x will multiply by the numerator, and on this side the x will just multiply into the 1, giving just x over here. So therefore we're going to have x, sorry, it's the wrong color, we're going to have x all over 1 plus x squared is less than arctan of x, which is less than x. Is this the same as what we got in the beginning? It is. So that is how we answer this question.